well, let's take a look back, okay? We had three main transformations. The first one was a translation. We just spent 3 days on that. I'm assuming we're good to go. The next one is a reflection. When you think of reflection, what's the first thing you think of?
A mirror.
A mirror, right? So when you look in a mirror, okay, you guys got to get it together, all right? When you look in a mirror, what do you see?
Your reflection.
Your reflection. Good. Is your reflection frontwards or is it flipped? It's flipped, right? It's inverted. So that's what we're going to see right here, okay? So let's take a look. We got triangle MNO. Okay, can I get a volunteer to help me out? What are point M's coordinates? Sophie? -1, comma, +1. There's point M. Great job. Can I get someone, Zach, for N?
-2, 4.
-2, 4. Thank you. And Oscar, where's point O?
Point O is -4, 3.
-4, comma, 3. That's right. -4,
Yeah,
comma, 3. There's point O.
that's better.
Okay? What do we call this shape here? Our beginning shape, our starting point. The pre-image. That's right. Now we're going to create an image of this triangle by reflecting it across the x-axis. If you have a yellow highlighter, hold it up real quick. Let me see who has a yellow highlighter. Okay. Our x-axis is going to be yellow. Where is my x-axis? Is it flat or is it straight up and down? It's flat. The x is our flat one. See that little x right there? That's okay. Please stop talking. Okay. So I'm going to highlight my x-axis in yellow, just like that. Okay. Now you guys see all those little math note squares up on the wall over there? What's the top middle one? You don't see them? They're right over there. What does the top middle one say? Reflection. And what do you see is going on with that word reflection? It's looking down into water. And you see that it's reflecting, right? So when we're reflecting, we only have two options. Okay, with translations, there was an infinite number of options. We could have moved it one to the left, one down, one to the right, one up, and every combination in there. Reflections are a lot easier because there's only two things we can do. We can either reflect it over the x-axis, or we could reflect it over the y-axis. So we're going to start with x. Good morning, Melanie. We're going to start with the x-axis, okay? And just like with the translation, how we talked about how... Okay. With translations, we talked about you have a bed frame, right? And you're moving houses. What do you do with that bed frame to move? You got to take it apart. You move it to the new place, and you put it back together. Does the bed frame still look the same?
Yes.
Yeah. So we're going to do a very similar thing here. Here's how it works. Make sure you're paying attention. I don't know why this says JKL. It should say...
Just kidding, LOL.
should say MNO. Okay? JKL's down on the bottom. So... here's the triangle, right? Let's pretend this triangle is you. And this yellow x-axis is like that lake that you see up there on that picture, right? Now you're looking down into the lake, you see your reflection, but your reflection, of course, is flipped. So if you're up above the lake and you're looking down at it, your reflection is going to be on the other side of it. You guys see what I mean by that?
Yeah.
Okay. So this triangle here is going to end up down here. What quadrant is this right here? Quadrant 3, that's where we're going to end up, okay? So let's start with point M. Point M, like we said, is at -1, 1. And we're going to ask ourselves, how far away from that lake is point M? What would your answer to that be? How many squares away from this lake is point M? If I count, how many squares was that? That was 1 square. Everybody see that? Give me a thumbs up if you see it. We're 1 square away. Okay. Now, when you're looking in a mirror, your distance is changing. If you get closer, your reflection gets closer. If you get further, your reflection gets further. So M is going to be exactly the same amount away from the lake as it is past the lake. So I go 1 space down, I go 1 space past, I make a new point. What is M now going to be called?
Reflection.
M what?
Prime.
M prime. You see how M and M prime are the same distance away from that highlighted axis? That's what we're looking for. That's a good reflection. Where are M prime's coordinates? Where's that at? -1, comma, -1. Okay. So far, so good. Let's take a look at N now. Again, we're treating each point separately. So n is not one space away from that lake. How many spaces away from that lake is point n? 4. 1, 2, 3, 4. I hit that line. How many spaces am I going to go past that line? 4. The same amount. 1, 2, 3, 4. I'm going to make a new dot and call it what? N prime. Thank you, guys. What are n prime's coordinates?
6.
-2, -4. Good. So see how m is closer to that mirror line? So m prime is also pretty close. N is a lot further away, so n prime is also going to be a lot further away. How many spaces away from that lake, if we want to call it a lake, is point O? 3. 1, 2, 3. I hit my lake, and how many spaces am I going to go now? The same amount. 1, 2, 3. Boom. What do I call this new point? O prime. And what are O prime's coordinates? Good. Now what I'm going to do is I'm going to connect my dots. Like I said, we got to put that bed frame back together now that all the pieces are in our new house. What do we notice about these two triangles? Does it look like we just took the top triangle and slid it down? No. They're flipped. It looks like a mirrored image. It's symmetrical on both sides, right? Kind of looks like the wings of a butterfly. That's one way I always think about reflections, like a butterfly, right? You see those butterfly wings, you know that you did your reflection right. Okay? Where was point N in relation to my pre-image triangle? It was on the top. Where is N prime now?
On the bottom.
On the bottom. You guys see that?
Yeah.
So we're flipping it around completely. Let's take a look at the coordinates. -1, 1 turned into -1, -1. -2, 4 turned into -2, -4. And -4, 3 turned into -4, -3. What happened to our coordinates from the pre-image to the image? What changed? The y coordinate. Did the x coordinate change at all? No. But what happened to the y coordinate?
They became negative.
They became negative, right? So what happened? Our y coordinate changed signs from positive to negative. Which is a lot easier than our translation rules, right? Our translation rules, we're adding 4, we're subtracting 3, we're subtracting 1, we're adding 8, whatever it is. With reflections, we're keeping all the numbers exactly the same. What axis did we reflect over here? The x. And what coordinate changed signs in our image? The y. So let's keep that in mind. I flipped over the x, but I flipped the sign of my y. Okay, that's going to come into play tomorrow when we talk about the rule. Give me a thumbs up if that process sounds easy enough to you. Makes a little bit of sense. Okay. We got another one, don't worry. Let's take a look at some vocab. Flip back to your vocab charts for me real quick. It should be a couple pages back. It looks like this. All right. So first, triangle JKL is the blank of triangle J prime, K prime, L prime. Thank you, Araya. Pre-image. Pre-image. In the transformation above, which is called a blank because of the way the figure flips across the x-axis. What's going to go in that blank? Can I get a volunteer to help me out? Zach? Close. Alyssa, what'd you say? Reflection, right? This is a reflection. These two triangles are blank, meaning they are the exact same size and shape. Who's got that one?
Congruent.
Congruent. Okay, thank you guys. Congruent. Same size, same shape. So triangle J prime, K prime, L prime is the what of triangle JKL? The image. Thank you, Raya. The image. Okay. The more we understand these terms, the more we're going to understand the actual work. Trust me. All right. Okay, what does this next example tell us to do? Reflect triangle JKL across what? The y-axis. So we've used our yellow highlighters for the x. We're going to take our second color. Hold up what your second color is. What second color do you have? Pink. Okay, green, blue, orange, whatever it is. That's what we're going to highlight our y-axis with. Is my y-axis straight up and down or flat? Straight up and down. So I'm going to highlight my y just like that. And now does it look like my triangle is kind of looking in a lake? No, the lake would be like flat. So we could think about this just like a standing mirror, like you guys probably have at home, right? Here's your little, we talked about like Phineas, right? The little triangle head Phineas. He's looking in the mirror. What quadrant is his reflection going to be in? Well, he's in quadrant 1. So where's his reflection going to be? In quadrant 2. Because we're reflecting over the y-axis, it's going to flip onto that side. If we were reflecting over the x array, we'd be in quadrant 4. Yeah, so take a look right here, right? We took this triangle, and it just jumped over that line. We're going to take this triangle, and we're going to jump over this line. So we're changing where we're reflecting it, but the process is exactly the same. It's very simple. Where is point J? Who can help me out with J's coordinates? Yeah, Zach?
3, 5.
3, 5. Thank you. Who's got K?
Me.
Angelina? 5, 2. Good. And who's got L? Sophie?
3, 1.
3, 1. Perfect. Okay. Now I'm going to count point by point. I'm going to start with point J. What direction am I going to be counting here? To the left. What I'm doing is I'm counting how far away each point is from my line of reflection. Everybody say line of reflection. Okay, I appreciate those of you with me. It's the line in which a figure is reflected across. I typically just call it the mirror line because that's easier to digest in our heads. So here my mirror line is the y-axis. So I'm counting how far J is from that mirror line. How many boxes away is point J? 3. 1, 2, 3. I hit that mirror line, and I'm going to have the same distance on the other side. So how many spaces am I going to count away from that line? 3. 1, 2, 3. I make a new dot, and I call it what? J prime. And what are J prime's coordinates? -3, 5. What changed from J to J prime? Did the numbers change from 3, 5 to -3, 5? No, the numbers stayed the same, but what changed? The x has now become negative. So my x coordinate changed signs. Interesting. When I reflected over the x-axis, my y-coordinate changed signs, and when I reflected over the y-axis, my x-coordinate changed signs. It's almost like things are inverted, like they would be in a mirror, right? So without counting, if we follow this pattern, what might the coordinates of K prime be? -5, 2. Okay, well, if I go to my graph from the origin, -5 up 2, that's going to be right there as K prime. Let's verify if that works. Here's point K. How far away is point K from that mirror? 5 spaces. 1, 2, 3, 4, 5. So how many spaces past that line am I going to count? 5. 1, 2, 3, 4, 5. Boom, I land right where I would have. Just like that. Okay? How far away is point L from that mirror line? Last one. 3 spaces away. 1, 2, 3. How many spaces past it am I going to count? 3. 1, 2, 3. Boom. What are K prime's coordinates going to be? -3 and 1. Zach, go ahead. What am I going to do with my 3 dots now? Connect the dots. We're going to connect them up. to make our new triangle. What direction is K pointing in my pre-image? K is pointing to the right. What direction is K prime pointing in my image? To the left. It flipped around. You guys see that? I can tell I'm boring some of you to sleep, which is fun. All right. I cut these notes in half from what I did last year, so be grateful for that. Okay, does that make a little bit of sense what we're doing there?
Yes.
Just counting. A lot of this is just counting. We just got to be careful of how we're counting and where we're counting to. So on the worksheet we're going to get, half of the questions have you reflecting over the X, half of them have you reflecting over the Y. I recommend you use your highlighters because I guarantee you the number one problem I'm going to see is people flipping over the wrong line. So just before you start counting and doing anything, just figure out, okay, it's saying Y-axis. I can just highlight my Y-axis just to make your life easy. All right? Because it's all mixed up, everything. Any questions I can answer about that? Good.